Hello again, and today's topic is operating modes, different types, and what you can use with SoftMotion. So in front of you we have EtherCAT module fieldbus manual for Lexium 32M, and here I already open operating modes list, and as you can see there is a lot of it. What you can really utilize in SoftMotion are cyclic synchronous operating modes, and you have three of them. You have position, velocity, and torque. SoftMotion is also using homing as we described in previous video, but you do not have any influence on it. However, with position, velocity, and torque, you can change those operating modes and you can use them. Now, today's topic is going to be CSV or velocity cyclic synchronous operating mode. Let's just briefly open it. So what you can see is brief description. The drive synchronously follows the velocity, and first thing is that you have a different target, which is velocity. It's not anymore position. Now we will see how to do this and how to enable the velocity, and also what is the difference between position and velocity when executing exactly the same function block, which is going to be mcMoveVelocity in our case. Let's go to codices. Now we continue with our project from previous video, and first thing we need to map correct objects. So we go to our drive. We have to map our objects in process data. However, we already mapped one parameter that it's used in our program, and this is drive error number. So we'll just copy this, because when we remap everything, this is going to be lost. We copy it, we go to process data. And now if you want to use any of those two additional operating modes, velocity or torque, you need to remap your outputs and inputs. We uncheck first mapping and we check the last one where we see target position, target velocity, and target torque. We'll do the same for our inputs. Now we go to mapping and we see that our mapping for drive error number is gone, so we will just paste it again here. Let's open briefly axis. If we go to scaling and mapping, we see that we already have automatic mapping for some of the objects, but not for set velocity, set torque. If we just build this, we see that we got the address. Now, how to switch the operating modes? There is one nice function block, which is called SMC set controller mode, and we need to call it. Let's first make an instance. SMC set mode axis 01 F2 text search SMC set controller mode. And now we need to call it again in motion function blocks. F2 instance call set controller mode. Okay. And this is something which you can do also if you want to move everything to the right, and I want to do it with one tap. So you click on a first, Shift Alt, you hold, go all the way down, release, and now press Tab and you shift everything. And we need to add axis. That's it. Visualization, we will enter our administration frame. SMC set controller mode. And let's provide an instance to our visualization. And we should go over this block and press F1. And here we have description, and what is interesting is this SMC controller mode. So position is 3 and velocity is 2. And this we will switch. Let's go to codices. Now we can load this program. Let's run and let's open axis control. So what we can do is immediately run controller, and we will also check certain things. If we say velocity 360, and let's put some acceleration and deceleration. And if we execute according to our scaling, the target velocity is going to be 360 units per second, and our scaling is 1 rotation, 360 units. That means that it's going to be 1 rotation per second or 60 rotations per minute. And RPMs is something that you feed your velocity loop inside the drive. And I will show you that SoftMotion already knows that and it does it correctly. But now we are in positioning mode and we execute move velocity and we simulate velocity. However, it's going to be still in position. And if we click here, we see target position, but we see target velocity. This target velocity is not used at the moment, but target position is. Now operating mode 8 here is drive operating mode. You can find it inside the manual that we mentioned in the beginning. And mode operating 9 is velocity operating mode. So let's stop this axis for a moment. First with proper deacceleration. Okay, axis is stopped. And we will now change the operating mode. So if we change this to 2, execute, it's done. And if we check in our drive, we see that operating mode is 9. Now, what is the real difference between position and velocity? Because if we now execute move velocity, we see again that more or less it's doing the same thing. For that, we will need a trace. And let's organize the trace that I can show you the real possibility of velocity and why you can use it. So now let's stop it properly. Axis is stopped. Let's go to trace and let's first delete everything. Add variable. So we'll use axis dot f set velocity, and we will also use axis dot f act velocity. Now to simulate the difference, I would like to stall for a brief moment the shaft of the motor. First, let's convert this to multi-channel. And because the motor is fairly strong, I need to reduce a bit the torque. And the easiest way to reduce the torque is to limit the current. So we will go to drives manual for the moment. So on page 157, we have current limitation parameter. We will read it out, check what is the value, and then set it to some small value that the motor can rotate, but that I can stall it with my hand. So we have 311C hexa, index, sub-index. Let's go back to codices. Now we have our administrative blocks. If we put 16 hash 3011 and we put sub-index 16 hash C and we execute, data length 2 and the value is 900, which is 9 amps. So we will put same index 12305 12 data length 2 and we will write 10. Now this is going to be 0.1 amp. limitation. Now let's first put the controller mode to position. We can see that this changed to 8. And let's now run our trace. And we run, and then I will try to stall. So let's stop. And let's go to trace to analyze. Stop trace. Now what you can see here is where I stall it. You see that actual velocity went to 0, but then velocity went extremely up, more than 2 times the speed. And the reason why is because positioning needs to catch up. That's why you have an overspeed. Now let's repeat the same test, but with velocity mode. Download trace. And we change velocity mode. And we go to axis and we execute and make a stall again. Let's stop. And let's stop the trace and analyze. Here we see also a drop. When we stall the shaft, then velocity went back and continue with more or less same velocity. So this is the main difference between those two operating modes. Hopefully you will understand when and how to use one or the other. In next video we will cover torque mode. And that's it for today. Thank you for watching. If you like it, give it a thumbs up. Don't forget to subscribe, and I'll catch you in the next video. Bye.